Trying to talk off your screen.
Thank you, everybody, for taking time out of your day to discuss high-performance HVAC coatings. My name is Dan Lusk, like Jeff said, with Heresite Protective Coatings. I've been in the high-performance coatings business for over 40 years and have been particularly directed to HVAC coatings in the last 5. So, like Jeff said, this is our second webinar discussing technical aspects of these coatings. Just a little backup here. Heresite was founded as a coatings company specializing in phenolic resins in 1935. In the 1960s, we invented the process of coating HVAC guard coils with a thin film high-performance coating. So we pride ourselves on being the performance leader in HVAC guard coatings, and our customers rely on us for the highest performing finishes in the most demanding environments. So today, what I hope to do is offer enough information on performance testing so you'll feel confident in the future recommending the right Heresite coating for your project in your heat exchanger. A big part of that is giving you access to resources that can assist you in the future in finding information regarding your environment and the right coating for your environment. So this is what we do every day. We extend the life of heat exchangers. I lay awake at night dreaming about this. We fight corrosion, both from salt air and chemical exposure. And it's really about increasing the long-term efficiency of the coil and offer a better return on investment for you or your customer. So HVAC coatings are unique. You can't go down to the store, Home Depot, and buy paint and expect it to perform. Number one, it's got to adhere to bare metal, mostly copper and aluminum, and it's a thin film coating, 1.5 or 1 to 1.5 mils dry film thickness. For those of you overseas, that's really 25 to 40 microns. And it's that thin because we're concerned with heat transfer loss, and it has less than 1% impact on heat transfer loss. So it's got to provide maximum corrosion resistance, even with that thin film, and minimize, like I said, heat transfer loss to extend the life of the HVAC unit. So a typical paint is 4 to 7 mils. Let's say a primer and a 2-coat finish system. That's what most people that apply high-performance coatings are looking for. And we're only 1 to 1.5 mils. So if you were to take a conventional primer finish system and put it on that coil, it can drop as much as 80% in heat transfer. So these are really unique coatings, and they require some special testing. So really, this coating has to do a lot in a lot of different environments. Marine and coastal, corrosives and chemicals we'll talk about, humidity and immersion really impact the performance of the coating and the corrosion of the coil. And then there's temperature extremes as well. So it all starts with us with research and development. We have our own chemists that work long hours on the testing that we're going to talk about. One of the things that's very helpful for us, because we've been around so long, we've worked with OEMs, coil manufacturers for many years, meeting their needs and the different environments that they face. We have over 60 years of market data, and we have the most extensive test data in the industry. And I'm going to go over that. Most of our testing that we do is in-house. There are a few things we have to send out. So we have on our 3rd floor testing area a lot of really high-tech equipment. And another thing that we focus on now is our extensive test data and work that we're doing on new generation products, which I'll talk about. So if you were to look at our P413 baked phenolic epoxy technical data sheet, we have over 27 different test results that we have listed on there. These are just some of them. So I'm going to spend 3 hours going over each one of those. No, I'm not going to do that. But I'm going to point out some of the things I think that will be helpful for you in deciding what product to use in a particular environment. So the most basic tests that are done are called physical property tests. And these are done by most coatings companies. And it tests adhesion, flexibility, hardness of the coating, and abrasion resistance. So this is done by most paint companies with all of our coatings, but we need to go far beyond that. So let's talk about really the most popular environment that our coatings are used in to protect a coil, and that's the salt air environment. Our products are selected for both coastal and offshore marine environments. So this involves really environments that have different temperatures, humidities, dryness, and in various parts of the world. So, for instance, the Space Coast in Florida and the US is a particularly difficult environment because of the salt air concentration and the humidity. Dubai in the UAE has a very salty environment, but it has very dry air with humidity at night. And that poses another particular problem because there's not rain to wash off the coil and do natural washing of the coil. So different parts of the world have different challenges, and we have to meet all those challenges. So salt air testing, they're just standard tests. So we understand the performance, again, in high humidity and even dry air environments. Our P413 is our baked phenolic epoxy. It's ideal for offshore environments, what we call C5 environments, and it really provides the maximum protection. Just a baked on finish, particularly a phenolic, just performs better outside in difficult environments than an air dry coating. In the industry, this is the performance leader. Most of our air dry spray products are used to fight corrosion really in coastal environments throughout the world. On the globe, where I've got Southeast Asia, it's basically a bunch of countries that are big islands. That's a particularly difficult environment, and they use a lot of our air dry coatings. The most popular tests that people run into and with HVAC R coatings is really the industry standard that's used for evaluating these coatings. Like many of our tests, this is done in-house. The picture on your left, you can see that's our fog machine, which has constant salt air mist that goes over to evaluate the coating. So we have what are called coupons. You can see it at the right, which are aluminum panels that are sprayed with our different coatings. And then there's a scribe that's done down the middle, basically a scratch down to the bare metal. And it's put in the machine, and the amount of hours that it's in the machine relates to the amount of salt spray hours that it can withstand. It's very important to have the scribe on there, and there are many companies that don't put the scribe on there because if there's any defect in the paint film, you want to make sure that it's still going to perform and it's not going to peel. While everybody uses this test, and we do too, to play, what I call the salt spray game, we don't think it's the best indicator of salt air performance. We don't believe it's real world. There's no atmosphere that's the same all the time, that's static. So we really think that there's a couple of better tests that are done to predict performance. And the most popular one that we really talk about is the cyclical weathering test. So this test replicates, the change in environments that a coating goes through and really is more realistic. It's a 25-week test where it cycles 72 hours of UV exposure, 72 hours of salt spray, and 24 hours of freezing. All of our coatings pass this ISO offshore cyclical weathering test. It's very important for us. We test our competition, and there's a number of them that do not pass this test. They may say they have high salt spray hours, but we don't think that they perform as well as our products using the offshore cyclical weathering test. So we think this is really important in determining how our products will perform in the most difficult coastal and offshore environments. So we have a few other tests that we do other than the salt spray and the cyclical weathering test. There's a SWOT test that's used. That's basically using acidified seawater rather than just regular salt water. And then we have a simulated saltwater resistance test also, which is at 2,000 hours for our P413 baked phenolic epoxy. But I don't know anybody that's got 4 tests that they do for salt air testing. Most companies send their panels off to third-party companies, and they do the ASTM B117 test, many of them without scoring it in the middle, and that's their standard. But we have to have more because our customers are more demanding. So we spend most of our time, and we have the most data on chemical resistance testing. These tests deal with, corrosive environments, like it says up in the upper right-hand corner in the yellow quadrant. But many times it's impacted by those things there that are around it. There's an infinite number of chemicals and environments and different concentrations and temperatures, humidity levels, that are out there. It's unlimited. We can't test everything, but we have enough information and a wide range of results where if we don't know exactly, if it's been tested in that area, we can offer a pretty good idea on how that coating might do. So there are 4 basic tests that we do, categories of test to evaluate the resistance, the chemical resistance of coatings with various liquids and fumes. And all of them are really important. The first one is the solvent resistance test. It's an ASTM test. We perform this on our P413 baked phenolic epoxy. It basically it judges the resistance, the solvent resistance to both MEK and acetone. Those are the 2 chemicals that are used. We do what are called 100 double rubs on it, which is forward and then back again. And then we evaluate the coating. So we may do that several times depending on what the coating is. We don't do this with our air dry coatings because they're generally used for salt air environments. However, as I'll talk about in a little bit, we do have some results with chemicals with those products. So this is really important when it comes to chemical testing, as solvents many times are involved in the environment that coil might be in. Spot resistance testing is what we probably spend the most time doing. We have a cured paint film, and in this one you can see on the top it's our P413, and on the bottom it's our coatings that are air dry coatings and some of our competitors. So it's put under what's called a watch glass, and you can see that at the top. It's a piece of glass where the solvent is put underneath. We put it in for consecutive 24-hour cycles. So every 24 hours we're inspected and we'll put the new chemical underneath it. That's done usually about 10 times consecutively, sometimes 8 times. It really depends on, the chemical and how corrosive it is, whether it's a really high or low pH. It may require more testing. So it's important to note that discoloring may happen, especially with a phenolic. That doesn't necessarily mean, though, that the coating is not performing. So on the bottom, again, you'll see our air dry coatings. We don't do as much testing with that, and you can see they're much smaller watch glasses. Where at the top, it's much more extensive. And on the top, this photo there is some testing we're doing right now with some new generation coatings. So fume resistance testing is done as well. And what you see there to the right is a fume hood. we've been around a long time. I'm not sure how old that is, but we've used it time and time again for many years. This is the area that fume resistance testing is done. It's important to note that there are some assumptions made when we do fume resistant testing. If it passes a spot test and a solvent rub test, there's a really good chance that it's going to pass a fume resistance test. Okay. There are some select chemicals where that may not be the case, but we kind of know what those are before they get here, and before we do testing on it. So we don't do nearly as much fume resistant testing that we did years ago. And you'll see when I give you the amount of tests that we've done in the past, we've got things really covered when it comes to fume resistance. And with the assumptions that we made with the different chemicals we have, we're confident that we've got enough information for you to make a decision. We do a visual inspection after the testing, and we might do some additional tests afterwards. So pH range, quite simply, it's used in all of the previous tests. In both the spot and fume tests, we test the pH range of it to see where it's at. And then it helps us determine what type of testing we need to do. If it's on the high or low range, we may spend more time on it. So on the bottom there, that's just a quick view of what you see on our P413 technical data sheet. The most acidic, lowest pH that we test is 2.4, which is glacial acetic acid, and the highest is sodium hydroxide. So where do you go to get information on making a decision on what you should use for your environment? So the most basic place to go and the easiest place to go is on our technical data sheets. The one on the screen is for a P413. This is a 7-page technical data sheet, 5-page, that has very detailed information on both performance results. The right side of the technical data sheet, you'll see there, that's 27 different tests that are done in that product. And there's more robust testing that's done in that particular product in many environments. And so there's more testing required of our coatings and of this coating in particular. So another place to get technical data information is on our air dry coatings, the back page. Again, this is mostly for areas that are salt air environments. So we don't do the amount of chemical testing we do on the P413. However, this is the back page of the TDS. There are some chemicals where this does very good or excellent in. So it really surpassed our expectations when it came to chemical resistance of this water-based hair shield new generation coating. Again, it's a very detailed sheet, and we've got a number of these different types of product in our salt air chamber doing continuing tests on it. So another great tool when it comes to chemical testing is what's called our chemical resistance guide. We have over 1,200 different chemical tests on chemicals that have different concentrations and different temperatures on different products of ours. So it'll tell you whether it's solvent resistance, chemical resistance, fume resistance, spot test resistance, so that you can make the right decision on what coating to use in your environment. It's available at Heresite.com, where you can download the PDF, or it's got a tool on there where you can enter the chemical and it'll give you the resistance. This is one of the sheets. On our most popular chemicals, there'll be a number of different concentrations and temperatures on there. This is for hydrobromic acid and hydrochloric acid. You see a number of them on there. So it's important when you're determining what coating to use is understanding what the environment is. And that means collecting information. What's the natural environment that that coil is going to be in? What's the proximity to salt air? Even if it's 4 or 5 miles off the coast, it could impact the performance of that coil and the corrosivity of the environment. When it comes to chemical exposure, if you're not the decision maker, or if you're looking for answers from maybe the owner, it's important to ask a lot of questions. And anytime you can get the safety data sheet of the chemical, that's really important because it lays it out exactly what's in there. So where's the coating being used? Are there cleaning products that are being used in that environment? Look around, look at who's next to that facility and see if there's any industries or factories in there that might be impacting the environment. But understanding every chemical that might be there and asking a lot of questions is very important in determining what coating could be used. Right now, our testing is really about coatings for the future. People want sustainable coatings, as the world does with all chemicals that are out there. They want more robust coatings for changing environments. And we need to meet the demands of your customer and, again, offer great ROI. So right now, what we're doing in some of the testing photos that I showed you there are testing for the next generation of coatings that are sustainable, more environmentally friendly, and more robust for the changing environments we have. So we have extensive industry experience. So doing this for 60 years, there's a number of thousands of different types of projects and environments that we deal with. And you can see on here that right there is meat processing and food processing, filling lines, like we do a lot of plants that have cleaners. There's a Lysol plant we put a coil in Pennsylvania, a Fresh Express salad plant that they do packaging of pre-made salads in Illinois. Of course, wastewater treatment, manufacturing of all different types, swimming pools, pharmaceutical plants, refineries, agriculture, again, food processing. Urban industrial environments is one that people don't take into account. So important to us is real world testing. So we have a number of tests going on. I'll just share a few of them with you. This one is in Charleston, South Carolina. You can see it's on a commercial building. It's right on the coast. And you can see on the left where they've taken one of our coastal sprayers, coastal applicators. They're taking our Hair Shield water-based product and they're spraying it on a small commercial unit to protect it. They spray the coil as well as the every part of the inside, the compressor and everything. So we've got that out there. The one on the right is one that's been out a while. And the one on the left, we just put out there about 18 months ago, and you can still see it's doing great versus the one that's not coated. We just did some very large heat exchangers for a power plant in California. It's a new plant, or I think it's a refurbished plant they're putting in. It's not far south of LA. But you can see the size of the unit that's being used there that we coated there in our applications factory. And they stack those one on top of the other so it cools the air before it goes into the turbine. And it's much more efficient when they cool the air. So this gets both salt air and a chemical environment. We're doing a test in Vero Beach, Florida. Again, it's our Hair Shield. It's out on, it's right on the beach. This one's on a hotel. It's been out there now. This slide's a little old. It's been out there probably 14 months, and it's doing great. You can see it on there. We're also doing a test in Vietnam where our coating on the right there, you'll see our Hair Shield is being used as well as two of our competitors. And that's been out there now. I think it's been about a year. When we take yearly pictures of that, yearly photos of it. But you can see how ours is performing on the right versus our competition. So just to kind of wrap up, why is performance testing important? Just to review what I said. It's a unique film, a very thin film coating. You can't take conventional wisdom about a coating and apply it to these films because they go on so thin. We're the performance leader. We have to have this information. This is what people expect from us. It's there, and all this data is information is available for you to access, so you can make the right decision and make an informed decision about your coil and your environment. And really, it's to maximize the performance and longevity of the unit. It's all about providing a better and improved return on investment for you and your customer's coil. Thanks for taking the time. Are there any questions?
And as we mentioned at the start, if you have a question, feel free to use the chat feature down on the lower right-hand side of your screen.
I did such a good job, Jeff. There's no questions.
Exactly. It was really great information.
Thanks, everybody, and thanks for considering Heresite. We appreciate it.
Yeah, it doesn't look like there's any questions. As I mentioned earlier, if you have any questions, after you think about this for, we've got one question.
Sorry. If a radiator supplier wants to apply Heresite coating that is not baked on, what would they apply? What would you recommend?
So we have our air dry coatings that can be applied by you, a professional in your market, because there are situations here, like Billy just brought up, where you don't have access to an oven or don't have the ability to ship the coil somewhere to have it baked. So our Hair Shield water-based coating is the best thing to use. It's at 15,000 salt spray hours, passed all of our testing. Let me pull it up here. There's the shield. So this is the highest performing water-based air dry spray-on coating. We have terrific results. It's the highest performing product in an air dry that we have. We sell this all over the world in coastal environments. It's our #1 selling product. It does a great job in those environments. And when you look at the back of the technical data sheet, it's good for mild to medium chemical environments as well. So that's the product I would recommend.
Another question came in. How do you estimate heat transfer loss?
It's done by most of the heat transfer loss data we have is done by some of the big OEM coil manufacturers. A year and a half ago, Train did a test with our products. So we haven't done one on our own in a number of years because our OEM good customers do them regularly.
It's a test called, it's a wind tunnel test, and that's where we get the data back that shows we have less than 1% of heat transfer loss. Another question that came in, is there any effect on coil performance?
The only thing that it would impact is heat transfer loss, and again, it's less than 1%, but it impacts the long-term efficiency of the coil. So yes, it has an impact on coil performance over the long haul.
What's the warranty period you can give to the users?
So we have a 1-year warranty that we provide. Many of our coastal sprayers that spray our air dry products, they're dealing with salt air, because this is mostly about application with those products, offer their own warranty that can go anywhere from 3 to 10 years, depending on where you're at in the world.
Great questions so far. Are there any others?
My contact information is going to be on the screen here in just a minute.
Does the coating give you savings on energy bills?
Again, over time it does, because when you're increasing and extending the performance of the unit over time, it's going to save money. So yeah, absolutely. That's usually that, and replacement of the unit are the two things that drive people wanting a coating on their coils.
Are the application instructions for air dry products on your website?
They're on the technical data sheet. They're very specific and very detailed. So everything from the type of spray units used, the viscosity, the pressure on your pumps. And if you follow those, they're very detailed and very helpful. And if you have any other questions, you can certainly give me a call or send me an email.
Great.
All right. Well, I think that wraps up our webinar for this afternoon. Again, we want to thank everyone for joining us this afternoon. Really appreciate you being here. As I mentioned, Dan's contact information is on the screen, so feel free to reach out to Dan if you have any specific questions. Otherwise, as I mentioned, we will be sending out a recording to all the participants, actually everyone that signed up for the webinar as well, that wasn't able to join us today because of time differences or whatever. So you can look for that in your email in a couple of days. So again, thanks again for joining us and have a great day.
Thank you.